And if you pull it this way, that angle is theta. Then all you're doing is you're taking the x component of the force, which is F cosine of theta, and then you're multiplying it times the distance. So what happens when theta is 90?
0.
Yeah, the cosine of theta becomes 0. And when theta goes greater than 90, what happens to the cosine of theta? Yeah, it starts turning negative. So it's just an easy way to break them down.
Yeah.
So say we wanted to find the work. We've got a 8 Newton force. It moves 15 meters. This angle is 30 degrees. How much work is done?
So you do 15 cosine 30 times, or times 8?
Yeah, it doesn't matter where you put the cosine of 30. You can either put the cosine of 30 to move it to the 8, the direction of the 8, or to the force. It doesn't matter. You'll basically just multiply them together and multiply by the angle. So then what if you had something like this? This is a 6 Newton force. This was 18 meters. Say this angle is 105 degrees.
So you do negative 18, or will you put the negative with the cosine?
The negative will come because of the cosine.
Okay, so you do 18 times cosine negative 105, or will you do negative?
Just 105.
105 times 6. So the negative will, okay, so when you put that in your calculator, come out negative.
Yep.
Okay.
Yeah, so that'll do negative work.
It's
And
on the left side of the graph, or of the...
just because they're pointing in opposite directions. That's the only reason why. It doesn't...
unit circle, it's on the left side, right?
Yeah, the 105 would be on the left side of it. But it doesn't matter which direction you have your work or distance pointing. So for like this, maybe this is 88 degrees. This is 8 meters, 3 newtons. Is this doing positive or negative work?
Positive.
Yeah, because the angle between them is less than 90 degrees. And then like, if you do this, this angle's 107. Are you doing positive or negative work?
Negative.
So that's how it works.
If you also went over an equation that I was, like we did one in class on a quiz, but a lot of the people kind of didn't understand it.
Okay.
This one, or was it? Yeah, I think it was this one. They use like the I and J.
Oh yeah. So
That's the
B.
It's like B dot I.
Oh, if I is
Sorry,
that. Okay. So
This,
the dot product is the way you actually do it in like vector notation. That's what he's explaining there. So this is A, this is B, oops, BXI, BXJ. So the way the dot product works is you take, so if you do A dot B, you multiply the x components together. So you do AX times BX.
Okay, so you
And you add,
the Y's.
oh, this is Y. Yeah, AY times BY. And it doesn't give you a vector, it gives you a scalar
Okay.
quantity.
So it gives you scalar.
Yeah. So a scalar is just a number, like any number. So if you have like an AX,
Do you have to change it into a vector, or is it just asking for a scalar?
no, it's just asking for a scalar.
Okay.
It's asking for an amount of work done.
Gotcha.
There's not a direction on it. If you have an AX and a B, not an AX, an A and a B, then when you do the dot product, you don't end up with a vector like out here or anything. Graphically, it's actually going to be this area, I think. Is it the area of the parallelogram? I think it is. But you don't need to really worry about what it is graphically. You just need to know that to do a dot product with vectors, you take the x components, you multiply them together. You take the y components, you multiply them together. And you just add those two together.
Okay.
So if you were given a vector, say you had vector A of like 5i minus 10j, vector B is 3i plus 5j, what would the dot product be?
It'd be 5i times 3i.
And you drop the i's when you do it. So it'd just be 15.
Plus, well, it'd be negative, right?
Yeah. So it'd be negative 35. So what kind of work was done there? Positive or negative?
Negative.
Yeah. And that makes sense when you look at it, because A, graphically speaking, was 5 here and then negative 10. So it'd be like this. And B is 3 here and 5. So they're opposing one another. And then what happens if, say you had vectors that were perpendicular to each other. So let's say this is 1 and 3, and this is 6, negative 2. So your A is equal to 1i plus 3j. Your B is equal to 6i minus 2j. How much work was done? Or how much work will be done?
So it would be 0.
Yeah, so you do 1 times 6 equals 6 plus 3 times negative 2 that equals 0. That's because the angle between these is 90 degrees. So that's two ways to do the dot product.